Question 17. A projectile is fired from the surface of the earth with a velocity of 5 meters per second at angle theta with the horizontal. Another projectile fired from another planet with a velocity of 3 meters per second at the same angle follows a trajectory which is identical with the trajectory of the projectile fired from the earth. The value of acceleration due to gravity on the planet is, within brackets, in meter per second squared, given g is equal to 9.8 meter per second squared. This is the acceleration due to gravity on the surface of the earth. Options: option A 3.5, option B 5.9, option C 16.3, option D 110.8. This question was asked in CBSE AIPMT 2014. Let us go into the solution. A projectile is fired from the surface of the earth. So there are two projectiles. One projectile from the surface of the earth, another projectile from the surface of another planet with different velocities of projection. From the earth 5 meters per second, from the planet 3 meters per second, but angle of projection is same, trajectory is also same. Okay, trajectory is also same. Let's say that this is the trajectory. Trajectory means the path. Okay, we have two equations. That means same trajectory equations can be applicable for both the projectiles' path. Okay, let us consider there are two equations. I said no. Equation 1, y is equal to x tan alpha minus gx squared by 2u squared cos squared alpha. This is the equation of trajectory or equation of motion of the projectile. Equation 1. Here u velocity of projection as is shown here. Alpha angle of projection as is shown here. There is one more equation for the trajectory, which is y is equal to x tan alpha into 1 minus x by r. See, these trajectory equations represent the trajectories of both the projectiles. One projected from the surface of the earth and the other one projected from the planet. Let us use this equation for both earth and planet because trajectories are same, no? So earth and some other planet. Earth is also a planet, but this is some other planet. If the same equation is applicable for both projectiles, of course angle of projection is same. The range also should be same. The range should be same for both the paths. So for earth, first one we take for earth, okay, for earth. This is for planet, let's say. We know the formula for the range. R should be same, but velocity of projection is different. Of course, acceleration due to gravity will be different. We know the formula for range as. This is for range. For both earth and planet, same range. Because same equation of the trajectory. You know that R is equal to u1 squared sine 2 alpha by g1 for earth. For the planet, this should also be equal to u2 squared sine 2 alpha by g2. Because the trajectories are to be equal, of course alpha equal given. This is y and x are the variables. Range should be equal. So range on earth, this one, range on planet, this one, they have to be equal because the trajectories are to be equal. So sine 2 alpha we can cancel. Sine 2 alpha. We are supposed to find the value of acceleration due to gravity on the planet. So our aim is to find g2. So g2 is equal to u2 by u1 the whole square. From this equation we want to find g2. So u2 by u1 the whole square into g1. So u2 is given to be 3 meter per second. U1 is given to be 5 meter per second square. This is 9.8. So 9 by 25 into 9.8. Okay, so when you calculate this, you will get 3.53 meter per second square. Suppose if you feel the calculation a little difficult, 9 into 9.8, you approximate 9.8 to 10. This is 9.8. Okay. Approximately you can take it as 10 and find the closeness of whatever you are getting with any of the 4 options. Obviously you will get it closer to this 3.5. So the correct answer, if you take 9.8, you will get 3.53, but it is given up to 1 decimal place, so the answer is 3.5 meter per second square. So option A is correct.